All right, so according to this software, I am 87% of a person. Is that what we're seeing here, John?
Yeah, that's what we're seeing.
Yeah, awesome. Hey folks, we are in the Auto Mechanics Technology Program on the Wilmer campus today. I'm here with my good friend John, one of our faculty members. John, would you just unpack for us kind of your background really quick, who you are? There's another faculty member here, if I'm not mistaken.
Yep, Kevin is our other faculty member.
And then we're going to jump into some stuff, but I'd love to hear about your background and with the program.
So I actually went to school here as a PSEO student.
Okay.
Way back in the 90s. Worked at a few different places around the Wilmer area. Worked at a co-op. Worked at a dealership, worked at a independent shop, and then I kind of got tapped to apply for a job here, and I've been teaching this will be my 21st year teaching.
21 years, awesome. And then Kevin is the other faculty member?
Yep, Kevin's the other faculty member. He's kind of nearing the end of his time as a faculty.
Yeah.
So we'll be actually looking for a new instructor next year. He started in '98.
Okay.
So he's got a lot. I'm still the new guy at 21 years. So.
Yeah, awesome. And when people think about auto mechanic technology, usually my experience, the average person experience is something's wrong with your car. You bring it to a mechanic, those garage doors close, magic happens, and then it comes back fixed. But a lot of what the magic
Hopefully
is behind there.
fixed.
Yeah, that's a lot of what this program looks into.
Yeah, so we spend a lot of time on just understanding the different systems of the vehicle and then actually physically taking them apart, putting them back together. And then it's a huge thing. Anybody that's brought their car in and got it back and it wasn't fixed right is fixed right the first time. All the manufacturers really, really drill into that. So, and a big part of that is finding the root of the problem.
Yeah.
So you can have a spark plug going bad and it can show up as a transmission problem. So to understand how these interrelated systems all kind of affect each other is a huge part of it. We kind of slice the car up, kind of like a slice of bread, and start picking apart from our ASE areas. That's our certification tests that you can take to become a credentialed auto technician.
Yeah.
So we have engines, manual transmissions, automatic transmissions, brakes, suspension, electrical systems, HVAC, and engines. I don't think I duplicated any there, but our classes are kind of broken up in those sections. So we're just getting done with 4 weeks of manual transmissions. We are going after spring break here. We'll be doing electric 2.
Okay. So
electric has technically 4 different classes, so we've broken that apart.
Yeah.
What the first year students will be doing is starting and charging and like gauges and instrumentation, but we kind of break all the things together, and then as we get closer to the end, we kind of make sure that they all fit back together again so they can look at those interrelations.
Yep, and it's incredibly hands-on. A lot of times students are physically working with pieces.
Yeah, absolutely.
Yeah.
Some classes are a little bit more classroom, but I'd say the majority of everything is in the shop or hands-on, working on things. I just told the students this morning, I don't like being in the classroom any more than them. I'd rather be in the shop.
Yeah.
But there's a lot of theory that we have to get everybody on the same page before we come down, theory and safety, before we come down to the shop and actually start working on stuff. So I would say on the average week, if we across the whole program, the average week we're in the shop or in the classroom about 4 hours and in the shop about 22 hours a week.
Okay.
So.
Awesome. And the program's fairly established. It's been around since
about the mid-'60s, so somewhere between 65 and 67. Auto mechanics was one of the very first technical programs, that first group of programs that was offered here in Wilmer.
Yeah, awesome. And it's only on the Wilmer campus?
Only on the Wilmer campus. In the past, it was in Hutchinson, and everything kind of consolidated over here in Wilmer.
Yeah, awesome. All right, so we're going to actually interact with some of the students, see what they're working on a little bit?
Yeah, we're going to check out some of their projects. We're just finishing up this class, so the students have done a manual transmission, an M5OD out of like a Ford truck or possibly a Mazda or a Ford Ranger. There's a couple different variations of them. So they finished that up. They're working on transfer cases and some axles and some other manual transmissions. So we're going to get a chance to look at that.
Awesome. I'm excited to see it. Let's do it.
We're going to go see.
All right. All right, we're standing here at our first station. Your guys' names again?
My name is Justin Contreras.
Justin? Miles? Great to meet you. You guys gonna be showing us something here?
Yeah, a nice PTU from a Ford Fusion from around the 2007 to 2012 models.
Okay, awesome. And what are we looking at here, John? What are they kind of showing us in these pieces?
So what the PTU is, it transfers power from the transmission to the rear wheels. So this would be an all-wheel drive Fusion. So this is how we get power to the rear wheels. This is a unit that we got here at the college because it was making noise and it got taken out of a vehicle. So it's just here for demonstration purposes where the students take it apart and try to find out what actually went wrong with it.
Awesome. It seems complicated. I don't know exactly how this would go back together. Are you guys first year or second year?
First years.
First years?
Yeah.
Wow, so you're just getting into it, but this is not intimidating to you? You figured this out?
A little bit. We kind of got everything what we figured out what was the problem with it from what we see. It's like, what was it again, Miles?
Bearing is shot.
Bearing shot.
Bearing is.
Of course it is. I can tell just looking at it, yeah.
Yeah. A lot of material in there.
Okay.
You can rub your hand on there and get glitter on it, so
yeah,
that's not optimal in any universe. But
how much time does it take to learn to do something like this or maybe diagnose a problem like this?
So we're just finishing up with a 4-week block. So we cover manual transmissions, transfer cases, 4-wheel drive systems, and we're just kind of finishing up. This is a little bit odd or different, so we're kind of taking apart some specific units right here at the end of the class. So 4 weeks, they have a good basic understanding of how things come apart, what to be careful of, how to identify the bad parts, and a good foothold into being able to diagnose and repair and decide if there's something inside here that can be repaired or if it's a whole new unit replacement.
All right, well, you've got another demonstration to show us?
Yep, we're just
All
going
right.
to move on down the line.
Well, let's
here.
move on over. All right, what is your name?
Dalen Sondergaard.
Great to meet you. And what are you showing us here?
Transfer case out of an 04 Silverado.
All right, looked familiar. I knew it was from an 04 Silverado, of course. So what is this here, John? What are we diagnosing? What are we looking for changing?
So this would be out of a pickup, again, kind of like the last one. This was taken out. It was actually one of our previous students had removed it and was like, hey, this would be something interesting for your students to take apart and try to diagnose. So it was out of his personal pickup. He had gotten a replacement unit, so he was nice enough to donate it to us at the college. This is kind of a little bit different transfer case. It has a clutch pack in it, so it has automated 4-wheel drive, so you can just put it in auto and you don't have to worry about when to put it in 4-wheel drive or when not to put it into 4-wheel drive.
Yep.
Takes a special fluid, and then there's a little bit more wear points inside.
Okay.
And Dalen is kind of figuring out that to get all the pieces to line back up and to make sure that they go back in the right order is fairly important. So I have each student kind of take apart a different transfer case, and then the whole group comes over. So even though over here we have a Ford transfer case, everybody gets to see what's inside of a Chevrolet transfer case,
okay,
or a Dodge, or a Jeep, or whatever it might be.
Yeah.
So this one we have a chain here. Power comes in here from the engine, and then through that clutch pack I can transfer power through this chain, and this is what actually drives the front axle, so I get the front wheels driving on a pickup and not just the rear wheels driving. What do we look at the chain there? We got a little bit of an issue?
We do.
We have a little alignment problem, right? This has got to be a little bit further down in there.
It does.
So Dalen's working on getting that put back together.
Okay, yep. So in this program, is this a lot of just the hands-on, looking at different, whether it's a transfer case or anything, just kind of get familiar, taking it apart, looking inside, putting it together?
Absolutely.
Yep.
We go through things in class. Some units will do some classroom things and then go right to cars.
Yeah.
In this case, there's not enough time to actually take transmissions out of vehicles.
Sure.
So we're just working on the bench in this class.
Yeah.
They just got done with a section where they actually did clutches where the transmissions did come out of the cars.
Okay, yeah.
So then we worked on the clutch in between the engine and the transmission. Now we're kind of working on the next part. So we kind of break the car apart in slices like a loaf of bread and kind of work through the vehicle and what needs to be done and diagnose. So
Awesome.
this just happened to be sitting on Dalen's bench here. This is a CVT that we get into a little bit more deeply in second year, but some vehicles have these, primarily Nissan, and this would be out of a front wheel drive, not a 4-wheel drive, but the vehicle actually is driven on a metal belt like this.
Oh, wow.
So all the power that goes to the wheels from the engine actually goes through that belt. And when we think about a belt, it's usually pulling a pulley. This actually, these little wafers in here are actually pushing. So in between, those all stack up like a long pole and push the other pulley. And the reason that the manufacturers have gone with this is I can infinitely vary how big this pulley is. So this shrinks down and this gets big, or this one can shrink down and this one can get big. If you think of like your 18-speed bicycle when you were a young adult, where you have all the different speeds, on a normal transmission we're limited by 6 or 12, however many speeds it has. This is literally 1,000 speeds. It can match the RPM to try to get the best fuel mileage is what everybody's kind of going for right now.
Oh, that's super interesting. All right, and then there's one more. This is the Ford?
So this is actually an older Chevy transmission. So Dawson here has an older truck. So we have some newer things going on, and I happen to have this older one. So this is actually out of like an 85 Chevy pickup, and Dawson just so happens to have a 70 Chevy pickup that, or a 77? 76 Chevy. But the transmission is the same model. His is a 4-wheel drive, so the back end's a little bit different. But if you come in here, if you see this gear, this first speed in this transmission is like almost a 7-to-1 ratio. So as fast, if you put this pickup in low range in the transfer case and put it in low gear in the transmission, do you remember what the math we worked out the other day?
Was it a 60-to-1?
At red line of the truck, you'd be going about 8 miles an hour. That's as fast as this truck would go. But I would be multiplying the torque 60 times by the time it got to the wheels. So that kind of pulling a stump out of the ground torque would be there, but then I lose out on my ground speed.
Top speed, Awesome. What do you think about just being able to kind of tinker in this program, get your hands on some actual components and get you in there and get dirty?
Well, I really appreciate being able to kind of take apart this one just because it's something that I've dealt with my own pickup. This transmission specifically is really cool just because it's in a lot of different vehicles. It's super simple, but it still gives you a good understanding of what's going on in a transmission. The M5ODs that we did, which are primarily like a Ford and Mazda, I believe, those transmissions were really good to do as well just because they're super simple, but you still get a good idea of, okay, what's going on? How is this working? Why did they design it this way? And John has done a really good job of just kind of showing us what's going on and just, explaining everything. And he's, great.
Seems like it. I've already learned a ton. I've only come down 3 stations. There's a lot more math involved than I would have guessed ahead of time. I don't know if I'd be cut out for it. That's a soft spot of mine. So awesome. Thank you so much.
Makes it easier when it's applied to something that you want to know.
That's true. Yep. Your names?
I'm Nasir.
Nasir?
I'm Mohammed.
Ahmed? Awesome. What are we looking at here?
We're looking at a transaxle on an Acadia. And then this the differential. So the back, the rear, and then this the shafts that goes in here that drives the tires.
Awesome. All right. So taking it apart, diagnosing it, putting it back together?
No, this is for a learning experience. Just, taking it apart.
Awesome.
See what's inside.
See what's inside,
Kind of figure out how it works.
How it got bad.
And
then there's a little rust right here, so we can see kind of had water damage.
Awesome. First year, second year?
First year.
First year? Both of you? Awesome. What do you guys think about the program so far?
Love it.
Love it?
This is puzzle.
Yeah.
I love solving puzzles.
Did you come into the program kind of already having sort of tinkered with stuff, or did you learn most of it after you got here?
No, I learned most of it on here.
This
was more, I learned on YouTube watching videos, but this is more hands-on.
And you like that aspect of it?
I love it.
Awesome. Anything you'd add, John?
So this is a design, again, for an all-wheel drive that's kind of been, we're getting into the 4-wheel drive, all-wheel drive type of vehicle. This would be out of an Acadia, as Nasir said. and there's no switches or anything inside, but it can still have four-wheel drive, which is important just this week in Minnesota.
Yeah.
So the way this system works, or it's supposed to work, is as soon as the front wheels start spinning faster than the back wheels, I know there's a slip taking place, and then the computer through these wirings activates a clutch and transfers power to the rear wheels. So you can drive all summer long, unless you're on some slick rain-soaked roads. This system might not activate at all, but when winter comes, this is going to transfer some power to the rear wheels. And what I believe happened on this one was the owner of the vehicle had different size tires on the front, not necessarily different size, but the fronts were wore out. They didn't get rotated to the back, and the backs were bigger.
Yeah.
So the computer thinks, oh, I need to try to get everything to turn at the same speed. So then this clutch is trying to work extra hard. Well, if you're on dry pavement, that can't happen. So this clutch pack inside here burnt up and actually locked up.
Yeah.
So now when they drove in the parking lot, you kind of get a little bit of the front fighting the back. So that's what's going on in this one.
I used to drive an all-wheel drive Audi, and they always wanted me to replace all four tires at once. I thought it was a gimmick by tire shops that just wanted to sell more tires, but it really matters.
Absolutely matters.
Okay.
You actually, to test if your tires are the same circumference, you mark the tires and you drive for 20 revolutions. So that's halfway across the parking lot, and those marks can only be about 1.5 inches off from where they started.
Okay.
So if you put a piece of string around, you stretch that out, that's only a few 30-seconds of an inch.
Right.
So there's not really any physical way you can measure it.
Yeah.
You have to actually drive it and see how much distance you travel.
Yeah.
Nope, not a gimmick at all. Very important, especially on an Audi, because that has a viscous coupling in it, and that's even more expensive. So.
Yeah. Oh, don't I know it? Yeah. Awesome. Thank you, guys. So this is obviously out of a fighter jet of some kind, right? No, it's not. No. Okay. What is this out of?
1998, 96 Chevy 1500.
That was my second guess. Yeah.
Yeah.
When we walked up, you were just hitting it with a hammer. Was that just for pretend?
No, there's two dowel pigs.
Okay.
One here, and then there's one over there. That have to get. You can put them in with the case, but then you'd have to pound it in, like I'm doing, which probably isn't a good idea because you don't have anything lined up. So I'm putting them in afterwards, and yeah, that's about what these are doing.
Okay, awesome.
So why are we working on this?
We think it ran out of fluid, so it got a little hot, and then this is supposed to sit like that.
Yep.
And there's supposed to be a gear, like one of these on here, but it got a little warm.
Ooh.
And now there's no gear on there.
Worn away, yeah.
Yep. So this is what drives everything in the transmission, so without that, it doesn't go anywhere.
Sure, yep.
For the most part, except for fourth gear.
Yeah. So the only option here would be totally replace this piece, essentially, right?
Yep, and this one.
And that one, yep.
This piece and this piece.
Yeah.
And the bearings?
Yeah, the bearings were all... Well, this is one of them. They don't even really spin anymore.
Yep.
Kind of. They're not doing too well.
Something looks a little off there.
Yeah, they got a little warm too.
Yeah.
Yep.
So this is actually a transmission that got taken apart in the last class, the clutches and drive lines. So what this vehicle got donated to the school, not moving.
Yep.
And we're actually, Chris and his partner Dawson actually went through, replaced the parts, put it back together, and that'll get put back in the truck. And it'll be a great vehicle for our students that don't know how to drive a manual transmission vehicle to get some practice in the parking lot driving a manual transmission vehicle. So that's what's going on here. So this is actually going back in a vehicle that's going to be back in the parking lot on the road. So.
Oh, awesome.
So, and I think Chris knows that working on an NV 3500 isn't a whole lot of fun, but learned a lot, right?
I'd do it again now that I know what to do.
Yeah. Pretty intimidating on the front end, and now it feels a little more comfortable.
Yeah. Yep. Definitely. Yep. Especially when you take it, you have to have it upside down to take it apart.
Sure.
So you can't see anything when you put it back together. So that's
you get all the gears lined up, and then this kind of goes on like a hood.
Yeah.
So they fought with it quite a bit to get it back together, but
Yep.
in the end, it all went in. So
And is this your first year in the program?
Yep.
Yep. Were you kind of a lifelong tinkerer of things like these, or did you come in not really knowing a lot?
Yeah, yes and no.
Yeah.
A couple years ago, I got into it with some friends, and
Yep.
then
Kind of as a hobby, learning
Yeah.
on YouTube, things like that.
and then I worked for one of his old students.
Okay. Yep.
So
yeah.
that's how I ended up coming here.
Realized you had a real interest in it and wanted to come here.
Yep.
Yeah. Awesome. Sweet. Well, thanks for showing us what you're doing here. All right, we're here with Kevin, one of our other faculty members in this program, and we're going to be working through a refrigeration system.
Correct.
Awesome. What are we looking at here? How does this work?
So this is basically what you would find under the hood of the vehicle.
Okay.
That's going to create the air conditioning system, the cool air. It's no different than any other refrigeration system. So
Sure.
your freezer at home, your refrigerator at home works on the same principle. Being it's a simulator, it really helps for us to be able to show students what's actually happening. Because if you look under the hood, you're going to see a bunch of hoses
Yeah.
and not much else.
Right.
A lot of the stuff is hidden. So I'm going to go ahead and turn this on. It's got an electric pump. Typically on a car, it's going to be driven by the fan belt.
Yeah.
The compressor, what we call it, that is basically the pump that's going to pump the refrigerant through. Over here, the main component is the condenser. This is the evaporator. The evaporator is up by the firewall or on the inside of the car. The condenser is out in front of the radiator.
Okay.
Right? With refrigeration system, you can't create heat, you can't create cold, but you can manipulate it. And that's basically what we're going to do. It's based on the transfer of heat, and it's really based on the change of state. So our refrigerant can be in a liquid form or can be in a vapor form. It's going to change twice throughout the cycle. The amount of energy to force the change of state is what's key.
Okay.
So what this simulator allows us to do is to see what's happening inside of the condenser. So the refrigerant's going to be pumped into this condenser, then we have these 3 glass tubes. Well, typically a condenser's all sealed up. You're not able to see what's going on inside there. In the condenser, as you can imagine, the vaporized refrigerant's going to condense into a liquid.
Okay.
So we'll see that as it goes through here. Then it's going to be pumped up to the evaporator, which is exactly the opposite.
Sure.
So inside the evaporator, the liquefied refrigerant is going to evaporate. That's going to take a lot of heat to force that to happen.
Yeah.
Okay. All that heat is going to be drawn from around the evaporator, and now with a blower motor, we're going to blow cold air into the vehicle, or cooler air. So I'll just turn this on. It'll just start pumping.
Okay.
Quickly, you'll see the refrigerant starting to flow through the condenser, and eventually starting to flow through the evaporator.
Okay.
Now you can kind of see it at partway through. It's still, it's getting to that liquid form.
Yep.
Okay, and then with the blower motor and the cooling fan, you can feel the heat here.
Yeah.
And you can feel the cool here.
Yep.
Okay? And again, we didn't create any coldness. What we did is took heat from here and we moved it out here.
Okay. Yep.
Okay? A lot of times what happens with a refrigeration system is it leaks, especially automotive ones.
Yep.
We get that complaint a lot. You know, how come my car leaks, but my home air conditioner doesn't leak?
Yeah.
You got to realize some of these components are mounted to the engine and the engine's moving.
Sure.
So that we have to have rubber fittings, we have to have flexibility built into the system, and that's what causes a lot of our leaks. With this, I can show students, I can put in a partial charge, and then they can start to see, oh, the change of state isn't taking place in the evaporator any longer, it's taking place earlier.
Yeah. Okay.
Likewise, if we put too much refrigerant in, then there's no change of state. Well, then there's no collection of heat, and we're blowing warm air into the vehicle.
Yeah.
So,
Fascinating. So this is just a kind of a very simplified way without having to see all the other parts of the car that just get in the way, kind of make it confusing.
Right.
This is just the heating cooling system isolated.
and that's when we fix air conditioning systems, we start under the hood.
Yeah.
And we make sure everything under the hood is good, because after that, after the evaporator, now we're going to have to mix the air and deliver it correctly.
Right. Yeah.
All of those parts are stuffed up under the dash.
Yeah.
Really hard to see.
Yeah.
Right? Gets complicated. We've got computers controlling it. So I really stress with students that we make sure 100% that this is working first.
Yeah.
And then we move inside of the vehicle.
Yeah, and what a huge advantage to be able to learn on something like this. These demonstrations are a huge advantage for students to be able to kind of just see it in isolation, get their
Right.
head around it before having to jump into the whole vehicle.
Right.
Yeah, what are we looking at here?
So now On this simulator, and we do use simulators, but we do work on cars as well.
Right, yeah.
We practice on our own vehicles. We work on customer vehicles. Yesterday and the day before, we had a ton of customer vehicles doing AC work, but we use the simulators more for being able to see what's actually going on, do some testing on stuff that you might take a very long time underneath the hood.
Yeah.
So I still have my refrigeration system right here. Really no different than over there, except it's an actual automotive AC compressor, belt driven. So this has an electric motor.
Okay.
The biggest part of this then is here's the evaporator, okay? And now how are we gonna get the air in the right place and at the right temperature for the passenger compartment?
Yeah.
So like I said earlier, diagnose all this first. We know that the evaporator is cold, but yet the air coming into the passenger compartment is not cold, right? So we have some problem with, say, one of the doors that isn't mixing everything correctly. We've got these little plastic actuators here. They actually run doors back and forth to accommodate that.
Yep.
And this simulator is more about that. I spend some time with the AC, but we spend a lot more time with trying to diagnose these actuators when things aren't delivered correctly.
Okay. And then this guy over here?
This one's much more than just heating and air conditioning.
Yeah.
But it does have that same heating and air conditioning system right here.
Okay.
Right. The nice thing about this one is it also has a heating system. So we've got a heater core. There's 2 lines that are right here.
Yeah.
So again, got the evaporator cold, heater core hot, and the heater core hoses just come from the engine. The engine runs, generates heat, and runs the hot antifreeze through that heater core, and then we just mix it with the cooler air to deliver the right air.
Yeah.
Right. And this one does a lot more, provides for a lot more diagnostics. We have engine diagnostics with this one. It's really nice for demonstrations. It is nice because it's got built-in problems, and I can send a student here, and oftentimes when we take a scan tool and we go to a computer, we find what's called diagnostic trouble codes.
Yeah.
And sometimes we get a laundry list of diagnostic trouble codes, and the students are like, oh man, I don't know where to start. And I'm constantly telling them not to get rid of the codes because then we're gonna lose a bunch of other information.
Right.
Nice thing about this is we can set it up with a case study, they call it. So it puts a problem in for the students to diagnose, and they can clear the codes as much as they want to. It comes right back again.
Right,
So it makes it kind of nice. So
yeah.
Sometimes I will set up like a car with a problem. I give it to student A, student B, and then by the time it gets to student C, it's got more problems in it because somebody, and it's not their fault. I mean, they may have unplugged something, and diagnostics told them turn the key on, check for voltage. Well, when you do that, the computer recognizes it's unplugged. Boom, there's another diagnostic trouble code. So now I got trouble codes that don't mean anything. And, you know, if you're the only one working on it, it's like, okay, now I got another code. Well, I must have just done that. So I just you know, ignore that, where the second or third student's like, oh, now which ones do I diagnose? So this is really nice for that, for being able to do that.
Yeah.
They say it runs, and it also has what's called idle stop. So on a lot of our newer vehicles, not necessarily hybrids or electric vehicles, you come to a stop sign, the engine shuts off.
Yep.
Until you step on the gas.
Yeah.
That has this feature. This is the first vehicle or simulator that we have that has that technology. So I'll be teaching a starting and charging class coming up next, and so we'll be looking at idle stop.
Yeah. These simulators, I mean, it's getting a little bit more complicated each time, but huge advantages to be able to learn as a student on these simulators. In isolation, kind of have these scenarios set up. Still getting your hands on things, not just looking at a computer screen to learn all these concepts.
Not just you know, just a graphic of what what it's supposed to, how it's supposed to work, not really the parts.
All right, that was awesome. Super fun to be able to walk to different stations and see all the differences. To me, it's all Greek. I mean, I don't, can't tell just by looking at it, but the students have certainly been equipped at kind of figuring out what these different components are and how to diagnose and take it apart. Take it apart's always been the easy part for me. Put it back together and it works. That's where the learning really comes in. Awesome. So let's talk a little bit more about the program. First, I want to give a shout out to some industry partnerships. I think you mentioned Snap-on is a big partner.
Yep. So we partnered with Snap-on a number of years ago, and we were able to purchase a package of scan tools, and myself and the other instructor, Kevin, got certified to teach. So as the students go through and work on the Snap-on scan tool and diagnostic equipment, they actually get certified in that. So that's a certification that they can take with them.
Yeah.
And it allows us to have some really cool equipment to use that we can get a better deal on software updates and that type of thing. The students also all take an end of program ASE test. So as we get closer to the end of the school year here, we're actually scheduling those tests where they're proctored in a lab. And it's just like the ASE test that any technician can take, but this has kind of the day-to-day shop things kind of removed out of it. It's more concentrated on theory. So it gives the students another certification, and then it also kind of lets them know if they're ready to take that ASE certification test.
Sure.
So they'd have a chance to do that after they graduate and get a little bit of time in a shop to get that certification.
Yeah, that's an awesome addition. So, and it's a 2-year program.
Yep.
The 2 credentials you can come out the other side with?
So most of our students go with a diploma.
Okay.
So then all of the classes that they take are taught by automotive faculty.
Yep.
Some of the students either bring in some credits and go after an AAS, or there may be PSEO students where they're already picking up some of those generals, so then they graduate with an AAS.
Yep.
Most of our employers, at least in this area, if the graduate isn't looking to advance into management or move up, they're very happy with a diploma.
Yeah.
We can remove a few technical classes so the students have free up a little bit of time in their credits to take some of those generals, but that's not what most of our students do. Most of them just want to be here working on stuff, learning the technical skills.
Yep, absolutely. And rough idea on program cost?
So our program is right around $13,000.
Yep.
You do also need tools in a toolbox and a multimeter.
Yeah.
So that's around $2,200-$2,300. And then we have a few different, we don't have any books, but it's online subscriptions for a couple different programs. So that's a few $100s more.
Yep. And then coming out of the program, you mentioned some of the career opportunities. What positions do we typically see graduates entering into? And
so most of our graduates, just about anybody that wants a job while they're going to school, there's a lot of opportunities to work in shops.
Yep.
Entry level, especially when you're going to school, it's not great money.
Yeah.
But that allows you to the students to cut their teeth and be a known commodity. So once they graduate and they have that diploma, they can command a little bit higher salary.
Sure.
So most of our students end up working at small town dealerships, independent shops, what we call fleet shops. So the the county of Candy, Ojai, city of Wilmer, those types of places. We have a few students that have ended up going to work in heavy trucks, heavy equipment, tractors, so that those mechanical skills are just in great demand. So our graduates are going to leave here anywhere from that $20 an hour range to we've had some students leave here at $25, $26 an hour. I just got contacted by a student that moved to Arizona, and he works his butt off, but he's making well over 3 figures at a Honda shop down there.
Okay,
so.
yeah, awesome. Yeah, so even at $25 an hour, or just kind of rough cowboy math and a salary, you're looking at 50, 55, 60, somewhere in there for a
Yep, after you kind of get your time in and make sure that you can fix those vehicles right the first time. That's just a huge part of it. That's what the customer wants, and they're the ones signing over the checks to the shop. So we have had a number of students go out and work for other people and then become their own business owners and have been very, very successful. So as I travel around the state, it's kind of just about every direction we go, we have graduates from here that own very successful businesses, as well as working inside dealerships and in management positions as well.
Awesome. And then, as we've seen with automobiles over the last, 30 years, especially in the last 10 now, we're seeing them become increasingly more dependent on computers. We're seeing things like automated self-driving or AI. How has that kind of trickled into our program?
So there's a lot of cool things happening. So the techie type of people, there's, crazy networks on cars and, uplinks to the cloud and all those type of things. But we spend a great deal of time just on the nuts and bolts of how things work. So we kind of bring that, the electric vehicle stuff, the self-driving car, autonomous vehicle stuff. We bring in chunks of that as it fits in, but that's a pretty small percentage of what most of our graduates are going to be working on.
Right.
Obviously, it's up and coming and everybody's getting ready for it.
Yeah.
But at the same time, we really need to get those basic skills, and that's what most people that come here really want to spend that time and learn those things. So.
Yep. Awesome. All right, well, last question. Let's say that I am a prospective student and I'm feeling like, man, this is something I'm super interested in learning more about. What should I do?
So I think the best thing you can do is try to seek out some of our graduates, and ask them what kind of experience they had here.
Yeah.
Go find their family's mechanic and kind of ask them and kind of get that feel for it.
Yep.
And then if they're ready to take that next step and come visit us, give our recruiting department a call.
Yeah.
Multiple times a year, we'll have time set aside for people to come in. We'll set up demonstrations, show them what an afternoon is like in the shop.
Yeah.
And, just really get in there. I always kind of explain it, picking what you're going to be doing is kind of like buying a car, and nobody just goes and, I'm just going to get this car and doesn't test drive it and doesn't do anything.
Right.
That would just be insane.
Yep.
So, spend some time. Come and meet us.
Yeah.
And talk to some of the graduates that have been through here. We're happy to take drop-ins.
Yep.
So call our recruiting department. You can schedule even if it's not on one of those days. You can come on down and find us.
Yeah. Awesome. All right. You heard it here, guys. This is our Automotive Mechanic Technology Program here in the Wilmer campus. If you're interested in this, reach out on the website, stop by, talk to recruiters, or look for one of our upcoming info sessions where you can stop in and kind of physically see the space inside here. But well, that's all we got for this time. And thank you so much for all of the teaching and time that you put into this today.
Well, thanks for coming in, Max.
Yeah.